All right, so the behavior, the end behavior, the end. Not how is the function behaving in the middle, like all the squiggly stuff, that's in the middle. But at the end, how is it behaving? If if I keep going this, so notice, if I give you some x values, let's say, so here at -2, 3, what if x was -3? If x was -3, y would be somewhere way up here. Notice, because this is going up here. Y would be somewhere way up here, right? So let's say y would be, let's see, 1, 2. How about +10? I'm just guessing at this point. What if x was -4? If x is -4, y would be some value way up there, way off the chart, way off my smartboard. Let's just say -30, I don't know, or +30 rather. If y of x is -5, we're talking about way the heck up there, maybe a +100. I don't know, I'm just guessing at this point. But I do know that the y value keeps getting bigger and bigger as x keeps getting smaller and smaller. So as x keeps getting smaller and smaller on the negative, look at -3, -4, f of x, remember that's what y is f of x. Remember I taught you that last week? Here's your x, here's your f of x. F of x keeps getting bigger and bigger up to a positive infinity. Because this never ends. This arrow means it never ends. It goes to positive infinity. As x goes towards negative infinity, look at this. F of x goes towards positive infinity. That's the infinity symbol. It's like a sideways 8. Put that on your notes. As x approaches negative infinity, right? So that's at the left end. That's at this end. What about this end over here? How is the function behaving? Let's see. If I were to extend this function would keep going down forever this way. Look at it. Let me keep extending it. Right? Just keep going forever and ever this way. So let's go back up here. If x was, so let me do x and f of x the way I was doing over here. Remember, f of x means y. If x is 3, let's say, right now you don't have to write this down. I'm just giving you some examples. If x is 3, f of x is going to be somewhere like way down here, maybe. I don't know, I'm just guessing. About negative, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. About -9. If x is 4, if x is 4, f of x is going to be way the heck down there. Look at it. If x is 4, f of x is like way down here. Okay. Notice that. 4, f of x will be probably about -20, let's say. Doesn't matter right now, I'm just estimating. If x is 5, look at, so as x gets bigger, look at 3, 4, 4, x is getting bigger, f of x is getting smaller and smaller in the negative realm. So if x is 5, let's see, here's 5, f of x is way the heck down here somewhere when x is 5. Let's say -50, I don't know. Doesn't matter. You get the idea, though. What's important right now is you're getting the idea of how f of x is approaching negative infinity as x approaches positive infinity. X is getting bigger and bigger. F of x is getting smaller and smaller. On this end, as x is getting smaller and smaller, f of x is getting bigger and bigger. So we're describing the end behavior. So this line is for that end. This line is for this end. So f of x is getting towards negative infinity as x approaches positive infinity. Okay? I'm going to go over more examples of this on Monday. I just kind of wanted to close this out in a small encapsulated form today, but we'll revisit this on Monday just to refresh. This will not be on today's quiz, like I told you. Today's quiz is going to be standard form, degree, and leading coefficient, stuff like that. Okay? But not on this.